and behavior part 2. This is the warm-up, but before I show you the warm-up, I want to explain this. These are like guided notes on how to describe end behavior. So this is what we talked about in the other slides. And here you see where is it? Okay. An even degree. If the leading coefficient is positive, then this is what happens. This is in a sentence. This is what's happening. As x becomes larger and larger in either the positive or the negative direction, the f of x, this is the f of x, the outputs are getting larger in the positive f of x approaches positive infinity, so it becomes larger in the positive side, because we have, I should have probably started with this, but you have your x and y coordinate. Here's your positive values, you have some negative values, and positive values. On the negative side, the leading coefficient, if the leading coefficient is negative, then you're gonna have a picture like this one. We said this earlier. Oh, that's not good. So you have a picture like this. As x becomes larger and larger in the positive, as let's see, as x becomes larger in the positive or negative direction, notice what happens to the f of x. The f of x is going down to negative infinity. So it's getting larger in the negative direction. Questions there? So this is an example of like y equals x squared. This would be y equals negative x squared. Okay, now odd degree. Let's look at the example y equals x to the third and y equals negative x to the third power. In this one, the positive leading coefficient, this one is there's a positive 1 right here, so the leading coefficient is positive. As x becomes larger in the positive direction, so as the graph is going this way, the y values are getting larger in the positive direction. As x approaches this side, the graph is going down here, so the f of x is going to get more negative. And finally, as x becomes larger in the positive direction, so as x is coming this way, notice what's happening to the graph. The graph is going to go more negative. It's going to get larger in the negative direction. As x becomes larger in the negative direction, so they're talking about going this way. So as x becomes more negative, f of x, or the y values, become larger in the positive direction, going up. Okay, so hopefully you were able to fill these out on your own PDF. on your own lesson 9. Let's do one of these as a warm-up. Match the picture with the equation. So let's see. Let me look at, I don't know, let's look at number 2. Right now, none of these are in standard form, so you can't tell the degree and you can't tell the leading coefficient. So for number 2, it's this. If I rewrite number 2 as in standard form like this, I'm going to focus on this right here. And what I get out of that is that I'm looking at 4. 4 is an even function, so that an even degree. So I know that something happens in the graph here, but I know that it's an even degree and it's positive, so it's going to do something like this. So for 2, I'm looking at A. Let's do one more. Let's do on number 1, you guys could multiply everything, and you're going to get a polynomial like this, and check the degree and check the leading coefficient to see which one it is. Number 3, let's do number 3 is 5x plus 15 minus 5x. I'm distributing the 5 inside, and here I'm seeing that 5x and negative 5x cancel out. So it's looking at y equals 15. Y equals 15 is a constant, so it's going to be just a constant line like this. So this one's going to be B. Okay, so that was the warm-up. You could do number 1 on your own. That was the guided notes. We're going to skip this part. So if you could just make a note for yourself that we're going to skip this part for now. I want to give you guys time to catch up on other assignments. And we are going to do 9.3. You're going to use today's notes to do this one. So look, we have m and n are functions of x defined by, so m of x is this and n of x is this. In order for you to describe the behavior, you need to focus on the leading coefficient and the degree. So those are the 2 things that you're looking for. Okay? This extra stuff like the 3x plus 8, that makes some movement inside of here that we're not really interested in at the moment. We're focused on the end behavior. So let's describe n together, and you could do m of x on your own. So looking at negative 20 x squared, I see that x squared is even and the leading coefficient is negative. So then that tells me that it looks like this. Something like this. And now you could describe the behavior. I'll let you decide how you want to describe it, meaning as a sentence, or you could use this math notation. So for example, tell me what happens in the left, tell me what happens in the right. So for example, as let me work on the left side. As x approaches the negative, the negative, as it gets more negative, the y values are also becoming, the f of x is also becoming negative, reaching negative infinity. And on the right, as x get as x approaches positive infinity, then the y values are going down to negative infinity, so it's getting larger in the negative side. And this is how you describe, this is one way to describe the function. Or you could use a sentence. Okay, and that is it. That is the lesson on end behavior. Let's see.